Alright, on this one we're trying to simplify this fraction. To get rid of the square root in the denominator, or we call that rationalizing the denominator, we're going to multiply the top and the bottom by square root of 11. So in our numerator, we'll have 4 square root 33. And then in our denominator, square root of 11 times square root of 11. If it helps you, you can rewrite it as square root 121, but it comes out to just 11. So we have 4 square root 33 over 11. When you look at the 4 and the 11, they have no common factors, so this will not simplify. Do not cancel a factor of square root of 11 with a factor of 11. Those are not the same. 14, we're simplifying the square root of 100 times x to the 6th, y to the 16th. Square root of 100 is 10. Now think about what your index is. Our index on this one is a 2. So the square root of x to the 6th, you can think of it as 2 going into 6 3 times, no remainder. Now remember, when you start with an even exponent, but then your answer has an odd exponent, you need absolute value. We need to show that this final answer is going to be a positive number. Even if x were a negative, we'd still have to make it positive for our final answer. And then y to the 16th, 2 goes into 16 8 times, no remainder. For the even exponents, we do not need absolute value. 15, we've got the square root of 32. That can be rewritten as 16 times 2. Square root of 16 is 4. Still have the square root of 2 there. Square root of x to the 8th power is x to the 4th. So you can think of that as like a 2 going into 8 4 times, no remainder. And then square root of y to the 16th is y to the 8th. Again, you can think of it as 2 going into 16, 8 times, no remainder. If there were a remainder, that part would stay underneath the radical. 16. Notice that we've got square root 90 here. If we do just a little bit of work on that third term, we've got 5 times square root 30 times 3 is the same as square root 90. So now we can combine those second and third terms. So we have 4 root 10 negative 1 plus 5 is positive 4. Square roots of 90. Now the square root of 90 we can rewrite as 9 times 10, because 9 is a perfect square. Square root of 9 gives us 3, so we have 4 root 10 plus 4 times 3 root 10. So that's 4 square roots of 10 plus 4 times 3, that's 12 square roots of 10. Add those together and you get 16 square roots of 10. Once we have those like radicals, we can add them together. We got the square root of 100 over the square root of 121. If it helps you, you can rewrite it as square root of 100 over square root of 121. So you get 10 over 11. That won't simplify any, so you're done. We're solving the quadratic equation by taking the square root. So to get rid of minus 4, add 4. So we have x squared equal to negative 25. To get rid of squared, we'll square root. square root of a negative, we'll just say no real solution or no real root. When you get to Algebra 2 at Trig, you'll continue with that because you'll be using imaginary numbers. 19, you got x squared equal to 36. To get rid of squared, we'll square root both sides. Make sure you do positive or negative on one side. Square root of x squared is x. And then on the right side, we've got square root of 36, that's 6. So we have positive or negative 6. If you check it, both of those answers will work. Make sure you have the positive or negative. Number 20, to get rid of plus 8, subtract 8. So we have 3x squared equals 75. Get rid of multiplying by 3, divide by 3. So now you have x squared equal to 25. To get rid of squared, square root. Make sure you do positive or negative on one side. So we get positive or negative 5. Square root of 25 is 5.